7.6 is about solving equations with exponents or equations with log or natural log. And there are 4 different types of equations that you need to know about. The first type is if there's an exponent on one side. The second type is there's an exponent on two sides. The third type is you have log or natural log on one side of the equation. And the third type is you have log or natural log on two sides. So there's 4 different things you need to know how to do. I'm going to go over all of them. I'll also show you that you can do all of these using the calculator, but for some of them it's easier if you do it by hand anyways. First example is exponent on one side. 4 to the x equals 11. Now to get the x out of the exponent, you have to use logarithm to get it out of there. So we're going to rewrite this as log base 4 11 equals x. Remember, that goes here. This shifts down like this. Now we're going to solve this. We're going to plug this into our calculator. Remember, you can't plug this in because it's not base 10, but you can rewrite it as x equals log 11 divided by log 4. Let's just plug that in. So we have log 11 divided by log 4, and x will be equal to 1.729, and I don't round, I just take the first 3 decimal places. Second type is exponent on both sides. So 4 to the x equals 1/2 to the x minus 3. Now the only way we can solve this, besides using the calculator, is to change those bases to be the same. If those 2 bases are the same thing, we can actually get rid of them. So we can change both of those to 2 because that's how they relate. So 4 is 2 squared, keeping that x, and 1/2 is 2 to the minus 1 power. 2 to the minus 1 is 1/2 to the x minus 3, keeping that the same. Now, when you take a exponent to a power, you multiply through. So we have 2 to the 2x equals 2 to the negative x plus 3. When those bases are the same, we can get rid of them, and we just are left with 2x equals negative x plus 3. Solve it. 3x equals 3. X equals 1. Now, if you want to solve this using a calculator, like you can for any of these problems, you're just going to set up both of those into one equation, into 2 different equations. So 4 to the x, and then you're going to calculate the intersect. 1/2 to the x minus 3. Graph it. And we're going to calculate the intersect, because where they intersect, that's what the x value is. And it says x equals 1, which is what we got right here. Now remember, you can use this method for every single time you're solving an equation. You just graph those, whatever's on the left into y1, whatever's on the right to y2, then you calculate the intersect. Third type of problem is where you have log on one side, like this. When you have log on one side and this x is stuck in the logarithm like it is here, we have to change it to an exponent to get rid of that. So we can rewrite this using the properties as 2 to the 5th equals x minus 6. We can just rewrite that equation like that. Then we can solve it. 2 to the 5th is 32 equals x minus 6. X is equal to 38. We can also check that with the calculator by graphing both sides into y1 and y2. However, you have to be careful because here it's base 2 and the calculator can't do base 2. So if you want to graph this side into a calculator, you have to rewrite that using the change of base formula. So you can graph that as log x minus 6 over log 2. That's what you're going to put into the first side. Log x minus 6 divided by log 2. And in the second side, you're going to press 5. Graph it. We can't see the intersect, so we need to zoom out. Now we're going to calculate the intersect. The first curve, notice how it says x equals 0, y equals It doesn't say anything, so we need to right over, press right until we hit that line. And the intersection is 38, which is what we found. So for a problem like this, it's much easier just to do it algebraically, but you can use your calculator as well. The last type is when there's two logarithms, like here. Well, I would say log on both sides, or whenever it shows up more than once. This is the last type of problem. For these, it's pretty complicated. The actual steps to doing this take a really long time. So for these, it's actually most beneficial to use your calculator, especially because while you're doing this, sometimes it gives you two answers, then you have to end up checking one of those answers anyways. So using the calculator and calculating the intersect will be the quickest method. However, you know you cannot graph this, and the reason you can't, so you're going to graph these two sides, y1 and y2, but you can't graph this because it's log base 6. So you have to change that using the change of base equation to where it's log 10 so you can graph it. So what it's actually going to look like when you plug it in is y1 equals log 3x over 6 plus log x minus 1 over log 6. So it's log 3x over log 6 plus log x minus 1 over log 6. That's how you use the change of base equation on both of those. That's going to be what you plug into y1. And to save us time, I've already plugged that in there. So log 3x divided by log 6 plus log x minus 1 over log 6. And for y2, of course, we're just plugging in 3. Graph it, calculate the intersect. What might happen on your calculator is you get something that looks like this. It'll say first curve, x equals 0, y equals nothing. What that means is you haven't selected a curve. It doesn't understand what you're looking for. So if you want to select a curve, you know that curve starts at a little bit to the right of x equals 0. So you have to press right until it gets on that curve like it is now. Then I can press enter. Second curve it seems to know about, so I'll press enter, guess, and it says x equals 9. That's going to be your answer.